Last time we looked at how we estimate an interval, a confidence interval, for a single proportion. And we looked on, and we did a little on how to do it when it was the difference between two proportions. So it's kind of where I'm going to start today with this general formula. So if you want to estimate the difference between two proportions, we'll call them P1 and P2. So the difference is P1 take away P2. Add or subtract the magic z-score, one of these. If I remember right, wasn't the book like everything was 95%, almost every question, for no particular reason? So
80, yeah.
Yeah, they used to like 80, and then they've kind of, I think they've kind of moved on. Maybe I'm wrong. But anyway, they go through little things. Yeah, they seem to like 95 now for no particular reason. So, excuse me. Just switching my phone off. There we go. So, difference plus or minus magic z-score, and this ugly looking thing, this is basically the standard deviation and sampling distribution. So we need to figure out what P1 is, what Q1 hat is over N1, P2, Q2, N2. I like to use 1 minus P1 here and here, but the formula gets so big when you do that, that we'll use the textbook version, which is Q1 hat is just 1 take away P1 hat. So one of the numbers is 0.7, the other guy's 0.3. Right? So if P1 hat is 0.7, Q1 hat is 0.3. And so you put the package together and you'll get an interval that represents the difference between the two different proportions. Now, let's talk a little bit of general truisms before we go straight in and pick some homework questions. Suppose I do an interval, a difference between them, and the interval ends up being negative 0.3 to negative 0.2, right? That could happen. You can get negative numbers. Now remember, this is P1 take away P2, right? This is first guy take away second. Since all the numbers in this interval are negative, right? They're all negative. Then doesn't that make P1 take away P2 probably is going to be negative? And then that means then that this is true. So if you get an interval with all the numbers negative, then you can be pretty sure that P1, whatever that is going to be less than P2. Does that make sense? If the interval is always negative, the first guy is less than second. So that would be the first guy gets less percentage votes than the second guy. So wouldn't that mean that the second guy would win then, if it was an election story? Okay. Now, suppose the interval with all the numbers positive. So what would that look like? Imagine it was 0.3 to 0.7, right? Like that, all positive. Then doesn't that mean that P1 is bigger than P2? At least there's a lot of evidence to suggest that that's the case. Because there are going to be some questions where they talk about this, and so we're kind of covered, right? Now, what happens if the interval has negative and positive numbers in it? Well, in that situation, you really don't know if one's bigger than the other, right? It might be, it might not. You can't really tell for sure. Right, so we're calling that kind of example, right? So let's look at some homework questions. I think the good thing about these questions is that although the numbers change and the story changes, The process is pretty much the same for every question. So you just look at the question and then you try and pick out the pieces that matter, right? So I'll make this a little bit bigger. I think we're going to do this one here, right? Which is about married couples. And then the next one's going to be a medical one, because I know a lot of you, some of you are going to be in the nursing program. Right, a random sample of 362 married couples found that 286 had 2 or more personality preferences in common. And then in another random sample of 574 married couples, they found that only 38 had no preferences in common. And P1 is going to be the 2 or more, and P2 is going to be the no. So we are going to create a 95% confidence interval based on all that stuff. So I'm going to write down some things and then you can see what I'm doing. I'm going to call it population 1 then population 2. Population 1 are couples that have 2 or more personality preferences. And population 2, that's going to be people that have no personality preferences. Okay. What do we know about population 1? Well, N1 is how many people were in it. So the sample of 362. And P1 hat was 286 of those people out of 362. That was true. In the second population, they did a bigger sample of 574. And the number of people who said yes to, do you have anything in common? And they said yes. Only 38 out of 574 said that. So now that I've collected all that information, let's put it together as a package. Well, I know that I'm going to use this formula to calculate the difference, which is what they asked us for. So what else am I missing? It looks like I need a Q1. Well, I also need this guy as a decimal, so I guess I should do that first. So if you take a sample of 286 out of 362, you get 0.79. And that makes Q1 hat. What decimal is Q1 hat going to be now that we know this one?
.21.
Yeah. Don't you just take that away from 1 and whatever's left, right? So the next one is definitely going to be much smaller. It's going to be 38 divided by 574. And the answer I got here is 0.0. Oh, what accuracy do they want? 3 decimal places, okay. 0.066. This one up here is okay because to 3 decimal places, it's just a 0. Now that makes, what does that make? That makes that 0, right? Let's find out what Q hat 2 is. 0.934. Gotcha. Right, so that's basically getting all the numbers that we're going to use. Now we'll put them together as a package. They want a 95% confidence interval, which is 1.96. So it's going to be P1 hat, take away P2 hat, give or take 1.96, a really ugly square root with a P1 Q1 over N1 plus P2 Q2 over N2. This guy here ends up being 0.791. This guy here ends up being 0.066, give or take. That fella. Yikes, okay. This guy times this guy divided by that guy. So 0.79, 0.21 divided by 362 plus this guy times this guy divided by him. So that's going to be a 0.066, a 0.934 all over 574. So I'll subtract those two first. And 0.791 take away 0.066 is 0.725, give or take. This horrible calculation. So 1.96 times the square root, 0.79 times 0.21 divided by 362, add 0.066 times 0.934 divided by 574, and we get 0.047 to 3 decimal places. So far, so good. All right, let's see where that ends up then. If you take 0.725 and you take that 0.047 away from it, you get 0.678. So that would be the lower limit. If you want to do the upper, you basically go 0.725 again, but you add that number. And that gets me 0.772. This guy here has a name. Sometimes they ask you for it in homework. Can you remember what the name we give to this bit at the end?
Margin of error.
Right. Which typically they give you the E, but that's who it is. Right, if I put that down as a little interval, 0.678 all the way up to 0.772, or if you like, 67.8% all the way up to 77.2%, would you agree that they are all positive numbers? In fact, quite big positive numbers in the scheme of things. And so wouldn't we be able to make the assumption that this population is bigger than this? Which means the number of people who have 2 or more personality preferences and are married is much bigger than the percentage of people who have no personality preferences in common. So I guess that's saying if you marry someone, you're probably going to at least share some personality traits. Maybe you both have a sense of humor or something, right? For instance.
Professor, I actually have a question.
Good, go for it.
So I was having problems with the homework, with the like 99 percentiles, because I understand how to do these and set them up and get the answers and everything, but with the 99%, it just was not liking my answers. So I don't know if I'm doing it wrong or if the
It could be
is just not liking it.
Yeah, it could be a rounding off issue. In some textbooks, I've seen this being that guy. And that might not seem like a lot, but it might mean like your 4th decimal place is a 2 instead of a 6. And that could simply be it.
On the homework, I had to round some of them. I think a couple of them either down 1 decimal or up 1 decimal.
Just to make it work?
Yeah.
So it sounds like you're doing it right. It's just WebAssign being awkward, for want of a better word.
Yeah, and I was just making sure because I had used like my 3 chances, just trying to guess what answer it wanted.
So, Denise, since you seem to find a workaround, you take your first answer and you normally tweak it by doing what direction, or do you do one, then you do it the other?
For the lower, I went down a decimal. So instead of like 0.678, I did 0.677.
Okay, so always round down.
But for
Gotcha.
the upper, I think I rounded up 1.
Okay, so they're just taking that interval and tweaking it a little bit by just giving you an extra little bit either side. So that seems to be what they're doing. That might also be a factor that although they're asking for 3 decimal places, they may be doing their calculations to 5 or 6 decimal places and only rounding off at the end, and that could also account for that weird little bit out. So if you remember what that question is and you shoot me an email, I can always go back in and give you the points because you really didn't do it wrong, right? It was just an awkwardness of calculation or WebAssign just being fussy. But the process was right. Since you're up and running, Denise, when you did it, the numbers were pretty much the same numbers. It wasn't like the numbers were just wrong. You were in the right ballpark, right?
Yes, I was in the right ballpark. But like you said, I started doing my math with the entire number. Like if it had 8 numbers after the decimal point,
I
went
used
ahead
it
and
kind of.
cut that all the way down to the bottom, and that seemed to be more accurate.
Well, it would be in general. So just being a lookout for that when you're doing it, that sometimes accuracy is going to cause issues that really aren't an issue. It's the right answer. It's how much did you round it off to, and did you do a right accuracy with that? Now I want to zoom back for a few seconds just to that homework question. Then we can look at the next one as well. Kind of give you an idea of what it would look like. Based on the calculation that we just finished, at least, our answers would have been 0.678. And on the other side, it would be 0.772. But if it was being awkward, make that a 7 and make that a 3, and that keeps them all happy, right? By that I mean make the last digit a 7 and the last digit a 3. That makes sense?
Yeah, that makes sense. Thank you.
Okay, now here's one of those stories I was talking about. It's more wordy than it needs to be. Explain the meaning of the confidence interval in part A in the context of this problem. Does the confidence interval contain all positive or all negative? Well, it's definitely all positive. What does this tell you about the confidence? And it goes on and on and on. So here's the choices. Because the interval only contains positive numbers, we can say that a higher proportion of married couples have 2 or more personality preferences in common. Correct. In this story. Now, I know that they randomly move these numbers around that are red. So your homework question might not have these numbers. And can you imagine in your homework question that disappeared? I'd have to switch places, but whatever, right? In that case, since everything is negative, wouldn't you be talking about that answer? And in a different world, can you imagine a different combination of numbers? It ended up being that interval. In which case, you can't make any conclusion at all. So if they're all positive, the first thing is bigger than the second thing. If all the numbers in the interval are negative, the first thing is smaller than the second thing. And if the interval has negative start but a positive finish, right, goes either side is 0, then you can't really say anything about who is bigger or smaller than anybody else. We good on that? Right, so that was why I brought that little interval thing in. Now, No, we don't want that. We've just done that. We've done a Navajo. No. I'm not doing the artifact one. Right, let's do a hospital one because I wanted to do a medical one. A community hospital, the Burn Centre, is experimenting with a new plasma compress treatment. Right, so this is what you'd probably call a medical or clinical trial. In this situation, a random sample N1 of 338 patients with minor burns received this new treatment. Of those patients, 256 had no visible scars after treatment. So they're counting success as being, you don't have a scar. You know, you get a little bit of, you know, you kind of burn that, you're cooking and some hot water hits your hand and you get blisters, right? You got a burn, that kind of burn, I'm assuming. So it's 256 out of 338, right? And so that would typically be called the experimental group, right? They're receiving the new treatment. N2 is, they received essentially the old treatment, which is, they didn't do the plasma compress treatment. So N2 is 434. And out of those, 101 of them didn't have any scarring either. And they would be called the control group. Okay, now let's switch back and show you how we would tackle that question. An awful lot of clinical trials have two groups. One group gets the new pill, the new treatment, the new course, the new chemotherapy, the new thing, whatever that thing is. And another group, the control group, they get the old treatment, right? The old pill, or sometimes no treatment at all, right? So placebo. Before we continue this question, this is not double blind. It's good if you can make it double blind, but this is not. How do I know it's not a double blind experiment? Don't overthink it.
Because one of them is the experiment group and the other one's controlled, so they know which one is actually getting the placebo or not.
Well, yeah, you know you're getting a plasma compress, right? I'm assuming that it's some obvious that's happening to you, and the other ones aren't getting it, right? Plus, the doctors, I'm sure, are knowing who they're doing it to. So I guess there is a way around that. I'm thinking about, can you imagine that this group here didn't get any treatment at all, right? Now, how would you control for that? Well, couldn't you do this plasma compress and have effect, you know, some ingredients in it that are meant to be doing, you know, scar reduction? And then seeing the second one, you don't put anything on it that's of any use, right? You just put water. And so you just give them the treatment. They don't know if they're getting the real treatment or they're getting the water version of it. And so you would be able to do that. And you could also not tell the doctors which one, the package that they're about to treat. You know, the guy comes in and says, I burnt my hand yesterday, can you do something about it, to your own doctor? He said, yeah, well, you're in this experiment, here's this plasma. Well, it might be, but it might be the water one, right? And so you could do it. But we got what we got, so we're going to work with it. Anybody want to guess what percentage it is? Because it was on the screen a minute ago.
95?
That's what I would have guessed, and then I had a quick look, and it was 90. So they do change the numbers sometimes. So I'm putting the formula down as many times as I can, because that's kind of one way of helping me, at least, and hopefully you, to remember what the formula is, because it's pretty ugly, right? There's a lot of bits to it. Would you agree, although it's a totally different story, isn't it essentially the same formula? Isn't it the same formula with the same kind of numbers? And have you noticed that I forgot to do something? Don't I need decimals if I want to make, my calculator happy? So I'll squeeze them in right now. And this time it's to 3 decimal places. So 256 divided by 338 is 0.757. And the other one is 101 divided by 434. And that looks like it's going to be 0.233. Superficially, would you agree that this new treatment is doing a better job at not leaving scars behind? Would you agree much higher success rate? We're now going to do a confidence interval, a 90% one. Now, if that confidence interval ends up being nothing but positive numbers, can't I then say with a fair degree of confidence, 90% confidence, that this new treatment does a better job than the old treatment? Right. So you now have a new treatment in the burn center. Hey, these new plasma compresses, they help patients recover, but they also get the benefit they don't scar as much, which is always a good thing. So here we go. P1 hat is 0.757. Take away 0.233, I put a little bracket around that. Give or take 1.645 times 0.757 times 0.243 all over 338 plus, because I never left enough room, 0.233 times 0.767 all divided by 434. Let's see what we get here then. These two guys, 0.757, take away 0.233, 0.524. This horrible mess. 1.645 times the square root 0.757 times 0.243 divided by 338, add 0.233 times 0.767 divided by 434, close the brackets, enter, and we get 0.051. And do a quick add and subtract, and we're finished. 0.051. That's nothing 0.473 and 0.575. Would you agree that everybody is happy here? All positives? Isn't that evidence that P1 is bigger than P2? So new treatment, more successful, old treatment. Now, for that actually to become a regular thing in a hospital treatment, there's other things that have to be done. I mean, let's try. Does anybody know that COVID has, not just COVID, but all the kind of treatments like COVID go through various phases? Okay, phase one. Do you know what phase one is for any new treatment? It's pretty standard no matter what it is, whether it's a COVID vaccine or not. Phase one is they test it for side effects and dangers. You do not really want to be in that group because they're not treating or testing, is it effective? They're just testing, does it kill you? or have nasty side effects. So you probably shouldn't volunteer for that unless they pay you money. But they do that and check. Oh, it has side effects, dry mouth. Some people increased appetite, some people less appetite. You know, if it's minor things like that, medication does that. You got to live with those, right? Not a problem. If people start having embolisms and killing over with heart attacks, probably shouldn't use it anymore, right? Trial stops phase 1. Phase 2, you take a small group of people and you test to see whether it's effective. Not a huge group, but just a small group. And you test to see if their antibodies are different. Are they showing that they aren't catching the disease, or are they improving their health and whatever the disease does? Then you go phase 3 and 4, which are typically are now put together, where you do mass trial on a large number of people, and you compare its effectiveness typically against whatever else is going around at the time. So if there are other vaccines, you compare it against that. If it's other treatments, you compare the success rate with that. So if you were doing the SCAR one, you would say, our guy gets an 80%, well, what is it? Our guy gets about 75% success rate. Right? But maybe there's another thing out there, right? Another treatment that's a new treatment, and it's also, you know, going through the testing, and it's 90% effective. Well, you're going to stop there, aren't you? Because the government's going to say, why do we want something, you know, that only does 75% when this other thing is just as good, right? It's just as safe and everything else, but it's 90% effective. So if they come across, let's say they have 2 or 3 vaccines in the next X number of days or weeks or whatever, they will be doing an effectiveness score on them. And typically what will happen is that the one that is most effective at protecting will be the one that will be the major one that they'll produce. Now, they may keep at least one of the others as a backup, just in case the bloody virus decides to mutate, because maybe the second vaccine will be better. For instance, do you know when you get your flu vaccine, it's never the same vaccine every year. Flu mutates virtually every year. So what they have to do is they have to have 2 or 3 vaccines waiting, and then they figure, you know, ready to go. And then as soon as the flu raises its ugly head, they check it out against their vaccines and say, number 3's the best one, and that's the one you get. Sometimes they judge it wrongly, and number 2 is actually the one they should have used, and you get a whole load of other things. Well, I rambled on a little bit, but it's good to know stuff, right? Medical stuff as well. So let's take one last look at what these homework questions look like. Now, it doesn't matter if you have got no medical background at all. Couldn't you do this question the way we just went? Just with the numbers, right? And here is a focus group talking about, I don't know, wood duck nesting boxes and which ones get more ducks in them and hatch more ducklings, right? Well, aren't you going to have one group against a second group, and then you go through the same process as you do every other time? Finito. Any questions about that before we move on to our final section, which is 7.4? Last chance. Any questions? So we feel comfortable about doing the P1 takeaway P2 thing? Give me a, why don't you say hi, and that way we'll take attendance right now. Now give me a chance to get set up. Hopefully that's everybody. Section 7.4 has two themes. We're only going to do the first theme today, and on Friday we will do the second theme, and that will be what we should have covered for this 2-week period, and that means homework for this coming Sunday is 7, 1, 2, 3, and 4. Right? Now, you should, I hope, get some deja vu out of this. We are going to estimate the difference between two means, sigma non. Now, before we do that, guy, let's remind you something we've done before. Remember, we found a 90, a 95, an 80% confidence interval for one mean when sigma was known. And the formula for that would be X bar plus or minus the magic score, depending on which one you want to use, times. Can anybody remember what goes here? And it is a fraction.
Oh, sigma over the square root of n.
Nailed it. Does that ring some bells, guys? Deja vu? Got to tell you a story here that came into my head. As you know, I've been teaching for a long time. What you might or might not know is I taught in Alaska for 2 years. So I taught in Alaska. I had 2 jobs in Alaska, 2 teaching jobs. I taught at the high school there. I also taught at the University of Alaska Southeast as a professor there. So I was at the high school. American high schools are fascinating places. That's one way of describing them. Anyway, I was teaching there, and I get in the morning, and I was walking by my classroom, and there was 2 students lying against the wall. Some about teenage students that they think the wall's going to fall over, so they have to lean on it really heavily so that it won't fall down. You know that way where you lean where your legs are at 45 degrees? I'm not quite sure how they do it, because to me, I would think you would fall over, but they did it. And they were one side of the door and the other side of the door. And I said, good morning, to which you get the limited language. You don't normally say yes, you just grunt, and various grunts mean yes and no, I suppose. So anyway, I walked by that night, and that was fine. And I just realized once I get into my classroom that I'd forgotten something. So I come back out and I go to my office and I pick up whatever is a textbook, and I'm on my way back, and I thought, I'm going to play with their heads. So when I got to the door and they were holding up the wall, I went and said, good morning again, like it was the first time. And they looked at me puzzled, and I went and said, have you never heard of deja vu? You know, that feeling that something has happened before. And do you know what one of them said to me? No, I still remember this. Will you stop talking Scottish to me? And I thought, oh God, I'm in the wrong job here. Doesn't even sound Scottish, but what the heck. I just shook my head.
That was in Alaska?
That was in Alaska, Ketchikan, Alaska. I knew that me in high school were probably not going to get on well together. So I spent most of, well, I had both jobs, but I focused on one after that. Okay, you remember this guy in general? So suppose I
Wait, I have a question.
Oh, go for it.
Do you speak what is it called?
Gaelic.
Gaelic? Is that how you say it?
You say it as Gaelic, yes.
Okay.
Do I
That-
speak
that's
it?
all.
Not very much. I know a very few words. Do you want me to tell you a phrase?
Yeah.
Sure.
Okay. Cudmil fialte. Cudmil fialte. It's really, if you translate it into English, it just says 100,000 welcomes. It's like an exaggerated hello. So, I don't know very much Gaelic. I wish I did, but I don't. So, are we good with this? Right. So, let's increase the world to 2 populations. Population 1, population 2. And let's put a story behind it. Right, population 1 is Scotland, right, and population 2 is America. I like those stories. And I know the standard deviation, sigma is known, right, for Scotland. So they're going to be called sigma 1, and for Scotland it's 5, and for America it's 10. And I'll make it my IQ story. And they got a sample of 100 Scottish guys, and the average IQ of them was 107, which is nice and high. And they got 200 Americans, and the average IQ was 103. We are going to calculate a 90% confidence interval for the difference between the mean of the Scots and the American. So we're not going to calculate a confidence interval for each separately. We're going to calculate a confidence interval for the difference between them. Now, since we're talking about mean, won't it be called mu1 and mu2? Right, mu is the mean of population. Right, here's the equation. We're going to use a version of this guy, but an adaptation. So the 90 thing is going to be x1 bar take away x2 bar. Does that seem reasonable? Like p1 hat take away p2 hat, right? Deja vu. Plus or minus the magic Z score for 90%. That seems good. Remember the ugly square root formula? Remember this guy? Right. If I cover that guy up, isn't that the nice formula when it's only one proportion? One proportion, difference in 2. One proportion, difference in 2. A very similar thing's going to happen here. You see this ugly square root guy? We're going to use him, and we're going to combine them into, and I just realized something I should have done first. I'm just checking that I'm using the right formula here, because I know this book phrased it in a weird way, and I don't want to get too, yeah. It's okay, it wasn't weird, I'm wrong. That guy is almost that guy. Right, mathematically, and let me just kind of show you where that sigma 1 squared over n is coming from. See if you do one big square root and you
We
put a
can't.
sig. Oh, you can't see anything?
No.
Sorry, thank you for telling me. Right. Right, that's going to be the magic formula, but I want to try and explain why that doesn't quite look like this guy. Right. If you take that guy, can't you split it up into that guy. And doesn't that just become sigma over that guy? So do you see that this guy is really very closely mathematically related to it? So there's your little ugly new fella. So continue the process. 107, take away 103, plus or minus 90%, 1.645, square root of sigma 1, which is 5, squared, divided by 100, plus sigma 2 squared, divided by 200. Are you happy about where all the numbers I'm getting are coming from? And you're going to be told all those numbers. It's not like you need to, you need to calculate like a Q1 hat thing. Right. So far, so good. Now, this is a little bit messy, but here goes. That there is 4, plus or minus 1.645 times a square root 5 squared over 100. Add 10 squared divided by 200. Do you see that the calculator actually will cope with this? I don't need brackets within brackets, which sometimes you do when the question gets really messy. Are we cool with that particular combination, right? So when I hit enter, I get, give or take, 1.42. So 2.58 all the way up to 5.42. So the difference in IQs between Scots and Americans is about 2.5 up to about 5.5. All these same question essentially we did earlier today. Aren't all of these numbers positive? Isn't that evidence then that Scots people have a higher IQ than American people? And there's a sentence at the bottom where you get 4 choices and that's one of them, right? If this had been all negative, wouldn't I have said Scots have a smaller IQ than Americans? That would be my conclusion if the interval had nothing but negative numbers. If I had a bit of negative zeros and all the way up to some positives right a bit either side, wouldn't we say that you can't really tell? And with an interval like that, you could have a kind of, be in Scotland probably, a newspaper article that would say something like that. Scots have an IQ 2.5 points higher than the average American. Why 2.5 higher? Right, at least 2.5, could be as much as 5, but guaranteed 2.5. Now that makes sense that you can even get if you want to, can you squeeze a little bit more information out of the interval than just say the first guy's bigger than the second guy.
So you got that number by just subtracting 5.42 and 2.58.
I hope I did it right. Yes. Yes, I did. I could do it on the screen just to make sure I did it. 4 take away 1.42. Yep, 2.58. Would you agree there's an awful lot of similarity between P1 hat take away P2 hat and X1 bar take away X2 bar? Okay, the formulas are a little bit different, but apart from that, isn't the process almost the same? Agreed? So for the next question, let's see if we can separate the sexes. So I'm going to go on the full screen right now, if I can make it happen. Oh, I've got to close this first, right? Okay. Now you're all on full screen. Okay. So I'm going to have two populations. Oops, excuse me. Population 1 is going to be the males in the class. Population 2 is going to be the females in the class, right? And I want to ask something about you that might at least have a fighting chance of being true, and it needs to have a number attached to it. So what can I do that might be true? Oh God, it's hard to think. You know, I'm going to get in trouble no matter what my question is, because it's going to be considered sexist. And the reason I want it to be sexist is I want a question that might separate the sexes. So it's going to be, okay, I can't think of a good one, so here's a bad one. How many times you have swore in the last month? How many times you have cursed in the last month, right?
0.
That is a good number, and that will be used. I think I swore at least a couple of times last night when I was watching the election thing, but I won't get into that. So let's get started. We'll do the guys first. Whatever you want to share, if you don't want to share, don't. I'm putting in 2 because I did swear at least twice. I don't swear normally, but I swore last night.
I got 0.
I got a 0. Any others?
I got 0 as well.
Anybody else? You know, this is dying a death here.
You mean like in the last 4 days?
No,
Or
in the last month.
Like,
God, you
like how do you keep count of that?
well, you might not
The
know
last
exactly. I
30
think
days.
it's about 8 times
The last
Or-
30 days, right?
in the last 30 days. You want to change any of your numbers? No, I need at least one more guy because we are dying a death here as far as data
I'll
goes.
just throw in like 10.
Thank you. Some of you curse more. I think if you're in the military, you
Count
curse.
that much.
Theo, you want to join in with anything else?
Well,
or
I
we
said
can-
I don't know how to count that much.
Okay. Right. Does that mean that you're at least 10?
Yeah.
Okay, we'll count it as 10. Right, I got a sample. That's cool. Okay. Females who want to volunteer, give me in the last 30 days. And 0 is the number.
About 35, probably way
God.
more than that.
Yikes. Okay. Well, we could be sexist. That's allowed. Go for it. I need some more there.
15.
15.
8.
10.
8. 10.
You want a big number, then I would probably say like 100
Oh,
something.
God.
It's like every
Are
other
you
word.
military?
I am. I'm veteran now, but
Yeah.
ex-Navy, so
Yeah, they have got a lot to answer for. Yeah. Okay, that's
how
a
we
good
communicate.
Yeah, same here.
Okay.
Little Caesars, so.
Okay. We're good. It wasn't the way I thought the data would come out, but one of the things in statistics is you should try not to preempt the answers. You should let the numbers speak for themselves. So in this case here, X1 bar is 22 divided by 5, which is what, on average, 4.4. And for the females, it's 50, 60, 68, 168 over 5, which is what, 3, 1, 3, 15, 3, 3. I better do that. I don't want to screw up. It's big. 168 divided by 5, 33. That's a 3.6. And let's say that somehow we know the standard deviation, and I'm going to make it the same number. That is 10. That's what makes these questions slightly unrealistic. Can you imagine that in most cases you'll never know the population standard deviation, right? So we're going to put this package together. What kind of confidence interval do you want us to get? 90, 80, 99? What number do you want?
Let's go 99.
99.
A 99. Ooh, okay. A 99% confidence interval. So if we get an interval that's all positive or all negative at a 99% level, oh, that's a QA. Who is it, Anna?
This is my brother. I need to hold him for a minute while somebody's doing something.
That's fine. What's his name?
Michael.
Michael. Do you know? Does he know his name yet?
No, he's only like 5 months. He doesn't really know yet.
Okay. Right, 99% confidence interval. Here goes. X1 bar, take away X2 bar, plus or minus for a 99%, it's 2.58. Square root of sigma 1 squared over n1 plus sigma 2 squared over n2. This guy here is 4.4. Take away 33.6, that's that bit. Plus or minus 2.58. 10 squared over 5 plus another different 10 squared over 5. If you do 4.4 and you subtract 33.6, you get negative 29.2. This calculation here is 2.58 times the square root of, well, I know that's 100, so that's 20 plus 20. Let's just cut the corners and get to the answer. It's going to be 16.3. By the way, that's called the margin of error, right? No matter what calculation you're doing, this bit here after the plus or minus is always called that. All right, let's take it. If you take a negative 29.2 and you subtract 16.3, you get negative 45.5. And if you take negative 29.2 and you add 16.3 to it, you get negative 12.9. Which means that there is a significant difference, at least in our sample, between women and males swearing. And the fact that these are all negative doesn't not mean population 1, right, is less than population 2. In other words, men swear less often than women. Which was total opposite of what I was expecting. But I think I know why. Our sample is tiny. Any other reasons for why it came out different from what I thought it would? Samples are very small. 5 people is not a big sample. Any other reasons?
Me and my big mouth. Sorry, girls.
100. Can you see how an outlier can really screw up your interval? The third one, I think, is just particular to this data set. If I had split the group differently into people who were vets or are still in the army, the forces, and the other group was people who've never been in the forces, wouldn't we probably detect a similar difference in vocabulary use?
What about age?
Age is another one. Maybe you could do one group was young and the other group, you know, whatever you decide young, right? Less than 30, right? More than 30. Can you do that split? Now, can you imagine all the kind of cool different ways a social scientist might look at these things? And he might come up with, I don't know what he's come up with because I haven't seen anybody do that, but can you imagine he might come up with things that older people swear a lot more than younger. Military people swear a lot more than civilians, right? And so on and so forth, all the different permutations. Is that good? Right. I want to share something about one of the reasons I don't swear much, which I don't, honestly, I don't. I was brought up in a big household, but I was brought up with a lot of girls right? All my siblings. My brother, who I vaguely remember, the first one in the family, he got married young and he went to the Navy, so I never really saw him. So he wasn't an influence. So I had my mum, who never swore, and my dad, who thought it was really fun to swear all the time. And so I guess I decided to go with the majority. So my sisters and me didn't swear. And my dad thought it was really fun to swear all the time. But he was a coal miner, which I think is not maybe military, although he was military during the war. I think if you're in a really tough job like coal mining or fishing or a lumberjack, I think he probably swear a lot because it's a very masculine orientated environment, and that maybe that generates it. But I never got it. True story to show you how I don't swear much. And this is an example of when I do. When I swear, I normally keep it for special occasions when something really annoys me. Or I hit my thumb with a hammer, right? I'll swear when that happens. So I'm quite selective about that. So this poor lady's going to have problems because if you ever hit your thumb with a hammer, how are they going to tell the difference? Right. So I was taking one of my, this dog's passed away, but it was Mac. And I took Mac out for a walk and he broke away from his lead and I ran after him and I tripped and I fell and I banged my knee and I could have sworn I broke something. I was in extreme agony. I was so badly hurt that I couldn't get up and walk, right? The leg was a goner. I thought, oh God, I've broken something really. If not, I've tore something. And I was in real pain. I mean, the tears were coming down my eyes and I was cursing like a sailor. I was swearing like nobody's business. And so I couldn't get up. So I thought I'll have to get my wife to come and help, you know, give me an arm up so I could hobble into the house and, you know, get to the doctor or whatever. So I picked up my phone and tried to phone her because I couldn't get through to her because it was outside. And she never picked up the phone. So when she finally picked up this phone, the first thing she heard from me was beep, de beep, de beep, 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 right? And she thought, what on earth is going on? And then once I calmed down, she came out and gave me a help. During all this time, the dog that I was worried about, who'd shot off, and the reason I was running after him, because he was running towards the main road, had stopped halfway to the main road, saw me lying down and thought, he's not chasing me. This game isn't fun anymore. And he came back and he just looked at me, cursing away with the tears rolling down my eyes, thinking, what are you doing that for? You know, he gave you that little turn of their head, that puzzled look. He was one weird dog. We love him to death. He's passing now, but he was a weird dog. He hated squirrels. Now, I know dogs hate squirrels, but he didn't just hate squirrels. We had trees in our yard, and squirrels live up trees. And squirrels would annoy the heck out of him by going on the end of limbs and squeaking at him. And he was virtually taking heart attacks, going like that. And he tried to climb up the tree. He would fall down again and keep doing it. And they would just laugh at him and laugh and laugh. Well, I think squirrels laugh, right? And they were having a great old time squeaking at him. Whenever he got tired, they would squeak again, so we would do it again. And oh God, he was a dumb dog. He was as dumb as a brick.
Our dog hates squirrels too. But my little sister actually gave nuts to the squirrels out our back door. And the back door is like glass, so you can completely see through it. And so now every morning this squirrel comes and puts its paws up on the window and she's
waiting for nuts.
Nuts. And she just hates it. But it'll just sit there watching my dog go nuts.
Yeah.
Some
animals, yeah. They're not nice. They're cruel to poor dogs. Although I'm glad he's never caught a squirrel, because I'm pretty sure it wouldn't end well for the squirrel. Pretty sure of that. Okay, let's continue. I want to show you now, as soon as don't do that. Try to cancel the wrong meeting. Let's look at some examples of that in our homework. So I need to go back a little bit. Take me a few minutes to do this. More. This is us on the last section now, the one we'll finish off on Friday. Almost there. Gotcha. There we go. Okay, it's loading up. Just make sure I got a question here. And this will be our last one for today because it will take a fair amount of time just to read it and do all the details. So, I've lost you guys. Where the heck are you heading? Oh, here you are. There. Now, hopefully you can read this. If not, I'll be reading it out to you. A lot of reading in this question, but it's basically population 1 against population 2. So the US Geological Survey compiled historical data about Old Faithful Geyser, Yellowstone National Park, from 1870 to 1987. Let X1 be the random variable that represents the time and intervals between Old Faithful's eruptions from 1948 to 1952. So that's going to be population 1 is how long between eruptions from 1948 to 1952. And this was based on 9,480 observations. And it took, on average, about 65 minutes. So if you went to Yellowstone Park and you wanted to see it explode, you might have to wait an hour, right? If it just happened and you just missed it, on average, it would take about 65 minutes, right, for it to do it again. You get that kind of ballpark figure, right? Now that was in the 40s up to the 50s, right? And then population 2 is the second population. And this was from 1983 up to 1987. And during that time, reading on a little bit further, that was 23,234 observations. And it took, on average, a little bit over 70 minutes. If I read on, sigma 1 is 8.91 and sigma 2 is 11.71. So all I've got in that white piece of paper is I read through that entire lot of stuff and I picked out the numbers that I needed. And now we're going to find a 95% confidence interval. So, are you happy about you just have to do a lot of reading and figure out who's 1, who's 2, who's X1 bar, who's X2 bar, who's N1, who's N2, who's sigma 1, who's sigma 2, right? 2 populations with 3 numbers in each case. Now we're going to look at the calculation of that whole thing. Would you say it seems reasonable that during this time span into this time span, that it's taking longer on average between eruptions? So like Old Faithful is slowing down, for want of a better word, right? It's taking longer between one kid's boom in the air and the next one. So a 95% will be this guy, give or take the magic number for 90, square root sigma 1 squared over n1, sigma 2 squared over n2. In fact, once you know the numbers, can't you pretty much ignore the story? Because won't the math be the same? So we have a 65, take away a 70.8. Well, that's quite a big difference, 5 minutes, but is it enough? Let's find out. A 90%er is 1.645. 8.91 squared over 9,480 plus 11.71 squared over 23,234. Are we good with those numbers?
The percentage, is it supposed to be 95?
It's supposed to be 95. Did I go and write the wrong one down? I
Yeah,
did.
you wrote 90.
So thanks for catching that earlier, right? So that goes there. So that's going to be negative 5.8 plus or minus this mess. So 1.96 times a square root 8.91 squared divided by 9,480. Do you think this is going to be significant? In other words, all the numbers are positive or all the numbers are negative? Do you think there's a big enough difference for that to show up? Any gut feelings before I continue? Yeah? Okay. I see some nods there, so I'm in your camp. I think there's going to be enough evidence. I think one of the reasons is, aren't these samples really big, which tends to make it easier to find relationships if there are any. So 0.234, what did they want here? 2 decimal places. 0.234. So if we subtract them, it's negative 6.034. And if we add them, it's negative 5.566. So that is the difference here. They're all negative, aren't they? Every single one of these is negative. Does it not make P1, no, not P1, does it not make nu1 less than nu2? In other words, in the 40s, early 50s, the time between eruptions is now less than it was in the 80s. So what we've discovered with this basically is an experiment, I guess. It's a, oh God, what's the word I'm looking for? Retro experiment, a retrograde experiment, which means you look at data that's already happened in the past, rather than looking at what's happening right now. And it looks like there is a definite, this guy here is smaller than that. Now, if this continued then, right into the 90s and then into the 2010s, and let's say today, 2020, wouldn't this number be getting bigger and bigger and bigger? So what we're noticing here, at least in this little snapshot, is the Old Faithful is taking longer between eruptions. Now, is that important geologically? I don't know. Maybe that means that it's calming down, right? It's not as volcanic activity, because basically it's caused by down in the, deep down, there's hot rocks meeting water, turns into steam, and once the steam builds up and up, it like boom, it shoots right out the hole. I mean, that's essentially what you're getting when you get that.